folks, welcome to another set of Chemistry 1 video notes. In today's lesson, the third lesson of Unit 5, you'll be learning about empirical formulas and percent composition. More specifically, we'll be covering standards C.4.6 and C.4.7, which asks you to be able to perform calculations to determine the composition of a compound or mixture, given the necessary information, and apply lab data to determine the empirical and molecular formula of a compound. That being said, let's get started. Right out of the gate, you should easily be able to find percent composition. It's a simple ratio of parts to a whole. I'm pretty sure you've probably done something similar in math class before. So imagine I had this mixture to the right. Say I mix together 504 grams of H2O, 92 grams of Na, and 142 grams of Cl. How would I find the percent composition of that mixture? Well, in order to complete our equation, you need the mass of the part and the mass of the whole. So let's go ahead and find the mass of our whole mixture. In this case, 504 grams plus 92 grams plus 142 grams, that gives us 738 total grams of our mixture. Next, you take the mass of your single part divided by the mass of the whole mixture. So maybe I wanted to find the percent composition of water in this mixture. It'd be 504 grams divided by 738 grams. This gives me about 0.683. Multiply that number by 100 and you find out that the water makes up 68.3% of this mixture. Go ahead and take a moment to calculate the percent composition of sodium, or Na, in your notes, based on the numbers for this mixture. I'll be checking this problem for points when I grade your notebook, so show all of your work. What if I gave you the percent composition and asked you to find the mass of each part? Could you do that? With a little bit of algebra, you can rearrange your equation to look like this. So say I knew that chlorine, Cl, was 19.2% of the mixture we talked about before. I divide that percent composition by 100 to get the ratio, then multiply that number by the mass of the whole mixture, 738. This gives me about 142 grams if I round. So, how do we find the percent composition of substances? Well, here you thought this would be hard, but it's actually just the same basic concept as finding the percent composition of mixtures. You take the total mass of the element you're looking for in your molecule and divide by the total molar mass of the molecule. Then multiply by 100%. So if we wanted to know the percent composition of hydrogen in H2O, we'd find the total mass of all of the hydrogen in the molecule. 1.008 plus 1.008 is 2.016. Then we find the molar mass of the whole molecule, which, as you know, we find by adding up all of the atomic masses for each atom in our molecule. The molar mass of H2O is 18.05 grams per mole. So we take the mass of the part, or the element, hydrogen in this case, and divide by the mass of the whole number, the molar mass. This gives us 0.112. We then multiply that number by 100 and find that hydrogen makes up 11.2% of a water molecule. Here's a little extra nugget of learning before we hit our last two big concepts. The difference between an empirical formula and a molecular formula is that the empirical formula gives you the simplest whole number ratio of the elements in a substance, while a molecular formula tells you how many atoms of each element are actually in each molecule. For example, CH is the empirical formula for both benzene and acetylene. These are two very different molecules. Benzene has 8 carbons attached to 8 hydrogens, while acetylene only has 2 carbons attached to 2 hydrogens. The simplest ratio of the atoms in both of these molecules is 1:1, so they both have the same empirical formula of CH. Glucose has a molecular formula of C6H12O6, but its empirical formula is CH2O, the simplest whole number ratio. The empirical and molecular formulas are not always different, such as in water's case, because H2O, 1:1, is the simplest ratio that we can get. But the molecular formula is always either the same as the empirical formula or a whole number multiple of the empirical formula. So, here we go. If I'm given the percent composition of different elements in a compound, how can I find the empirical formula? You just use all the information you learned before with a couple little extra tricks along the way. To make things easier, when you're given the percent compositions, you just pretend that you have 100 grams of your substance. Since percent means out of 100, when you do that, you can assume that each percent value is now just how many grams of each substance you have. Next, divide each element's gram value by its molar mass, or its atomic mass from the periodic table. When you do this, you're actually setting it up like a conversion, which we'll see in a minute. This will tell you how many moles you have of each element. Next, divide these mole numbers by the smallest mole number that you just got, and round to the nearest whole number. This will give you the molar ratio of each element to the rest of the elements in the compound. These molar ratio numbers will now become your subscripts in your empirical formula. If you have extra time and want to double check your work, start with your empirical formula, find its molar mass, then find the percent composition of each element. This should give you the same percent composition values that you started with. Let's do an example. So according to my problem, I've got a molecule with 55.8% carbon, 11.7% hydrogen, and 32.5% nitrogen. The first step is to just change all of those percents to grams. Next, we convert each of those grams into moles by dividing by each of those elements' molar masses. Now you might be asking, why are we dividing? Well, here's what we do. If we're converting 55.8 grams to moles of carbon, then we know that for every 12.011 grams, we have 1 mole, just like we did in the last lesson. So these are all just conversions, but we're doing it a little bit of a shortcut way. So now we divide each of these and see what we get. And each of those mole values are the ratio of our elements in our compound. Technically, we could use those as subscripts, but we don't really want decimals in our subscripts. So we want to find the simplest ratio by dividing by the smallest of each of these answers. So in this case, we're going to divide by 2.32 for all of them, and then round that answer to the nearest whole number if it's close to a whole number. In this case it is, because we get about 2, 5, and 1. So this tells us the subscripts for our empirical formula. So we're going to have C2H5N. And that is our empirical formula. Well, that's great and all, but what good is the empirical formula if we already learned that it only tells you the simplest ratio of the atoms in the molecule? One empirical formula could stand for dozens of different molecules. How can we go from here and find the molecular formula? Well, the short answer is you can't, unless someone was kind and generous enough to tell you what the molar mass of your actual substance is, or if you ran some experiments to figure that out yourself. If you're given the molar mass of your substance and the percent composition of each element, simply follow the steps from above to determine the empirical formula. Then find the molar mass of your empirical formula. Next, divide your actual molar mass by the empirical formula's molar mass. This should give you something really close to a whole number. That whole number is a ratio of the molecular formula to the empirical formula. So you just multiply each of the subscripts in your empirical formula by that number, and boom, you've got the molecular formula. If you want to double check yourself on this, calculate the molar mass of your new molecular formula. It should match up with the molar mass you were given. Let's continue our example from before. All right, so say we did some experiments and found out that the actual molar mass of our molecule is 129.2 grams per mole. We got to figure out what our actual molecular formula is. So to do that, we find the molar mass of the empirical formula first. That would be 2 times carbon's atomic mass plus 5 times hydrogen's plus 1 times nitrogen. And that gives us a total of 43.069 grams per mole. Then our next step is we take our actual molar mass divided by our empirical's molar mass. So we'll take the 129.2 divided by 43.069. And since they both have units of grams per mole, that cancels out. And the number we get, which is really close to 3, is just a ratio. That 3, we're going to multiply by each of our subscripts. So instead of C2H5N, our actual molecular formula is going to be C6H15N3. Well, that's all for today, folks. I hope you were able to learn something from this notes video. As always, if you have any questions, ask.